This isn't going to be an overly long lesson. Chances are you should probably be able to get your homework done. So real quick, we're going to pick up with something we briefly talked about yesterday. And if you remember in passing, I talked about what a Pythagorean triple is. A Pythagorean triple is a set of three positive integers, a, b, and c, where a squared plus b squared equals c squared. So the key word here is integers. Because if you remember integers mean a whole number. It's a positive or negative whole number. So in this case, they're restricting it to positive integers only. Okay, so that means no decimals, no fractions. And so they have to fit the form a squared plus b squared equals c squared. So I went ahead and listed a couple for you.
Isn't it
Okay?
5, 12, and 15?
3, 4, 5. 5, 12, 13. 6, 8, 10, 7, 24, 25, 8, 15, 17. There are numerous Pythagorean triples. These are just a few examples. Okay? I just picked them starting with the number 3, 5, 6, 7, 8. But there's numerous other ones. Okay?
Isn't there one
So-
like 16 and 14?
So anyway, based on those Pythagorean triples, we're going to go ahead and look at the next slide. And the converse of the Pythagorean theorem. The converse of the Pythagorean theorem, if you notice, states if the lengths of the three sides of a triangle satisfy the Pythagorean equation. So let's think about this. And let's try and fill the blank in based on our previous knowledge. If the lengths of the three sides of a triangle satisfy the Pythagorean equation, then the triangle is what?
Right.
A right triangle. Okay. Then the triangle is a right triangle. So what we're going to do now is we're just going to use that fact, and we're going to be given triangles, and we're going to have to determine if they are right or not. So if you notice that example, it says determine whether each triangle is a right triangle. So all I'm going to do here is I'm going to check. I'm going to see, does 9 squared plus 12 squared, does that equal 15 squared? If it does, it's a right triangle. If it doesn't, it's not.
It is.
So let's go ahead and try it. 9 squared is 81. 12 squared is 144. 15 squared is 225. What is 81 and 144? 225. So is this a right triangle?
Yep.
Okay, so this would be a right triangle. Okay, pretty straightforward. Let's look at another one. 4, 11, and 15. So what we're going to do, 4 squared plus 11 squared, does that equal 15 squared? So 4 squared, you know, is 16. 11 squared is 121. Does that equal 225? And the answer is no. So this is not a right triangle. Okay, so we've got another example we're going to look at, and then that will be it. By the way, are there any questions before I move on to that next example? Okay, the next example is a triangle with sides 12, 16, and 20, a right triangle. So this is one that you don't have a visual. So we've got to remember that the hypotenuse is always the what side? Largest side. So in this case, I'm going to take 12 squared plus 16 squared, and I'm going to see if that equals 20 squared. I know that 12 squared is 144. What's 16 squared? 256.
True.
Does that equal 400? Yes. So this is a right triangle, and this is all you're going to be doing today. This is the converse of the Pythagorean theorem. So what you need to do for me for tomorrow, okay, and you need to get this done, is you need to do 1 through 15 on page 470 and 471. Okay, 1 through 15, pages 470 and 471.